Everyone, let's continue. Mann-Whitney U-test. First of all, what is the condition behind this when we are going to apply Mann-Whitney U-test? What is the condition? Because this is one of the non-parametric tests when our data is not normally distributed and we would like to compare distribution of the two samples. Those are from different population. Then we will apply Mann-Whitney U-test. And in this test, we are taking one of the example that is the good example we will discuss here. Example is a study was conducted to compare the efficiency of the workers of two mines, one with private ownership and the other with government ownership. The researcher was of the view that there is no significant difference in their efficiency levels. So total tonnage of the mineral mined by the workers in one shift was chosen as the criteria to assess his efficiency. So basically what we are doing, 20 workers we have taken from the private sector and 24 workers we have taken from government owned mines, and now we would like to compare whether their output is same or there is a difference. So total we can see here, total number of this one is the minus are 44. Those are the workers. One stands for, those are the private owned sector. And this one is the two stands for government owned sector. So this one is these are the outputs. Last column is output. So let me start this. Average output of the workers from mine 1 is equal that of the workers from mine 2, and average output of the workers from mine 1 is not equal that of the workers from the mine 2. So we have already calculated with the help of the one of the software, that is SPSS. Now we would validate these results with the help of the Python. So private owned mines and government owned mines, now we can see here, right, equal variance is here. Right. Further is we can see equal variance not assumed, right, 0.017, right, because this value is less than 0.05. So that is why we can say, right, significance level, equal variance assumed and equal variance not assumed, right. So now finally we can say the total p-test 0.017, which is less than 0.05 but higher than 0.01. Therefore, we can reject the null hypothesis at 5% level, 5% significance level, which means that the average output of the two mines are significantly different from each other. And that is the miner of the two mines do not have the same efficiency. So now further we would run the same exercise we would conduct in the Python. And df is here is pd dot read underscore excel independent, right? This is the file we had opened. But before that, what we have done, import scipy as stats and import pandas as pd. So further we will go there, and we had opened this file, and now the miner, mine and output, the same file we had called here, right? One is for the private owned mines and two stands for government owned mines. And further is from scipy.stats import mann-whitney u. Mann-Whitney u, first of all, we had imported, and after that we had opened this data set, this degree, this one is the data frame, mine and output. Only these two columns we required, so we had opened. And now these are the statistics 0.0 and p values 2.2, but e to the power 16, right? So I had explained you how you have to read this. The p-value is this, and this is an extremely small p-value, scientifically expressed as 2.21 multiplied by 10 to the power minus 16, right? So this one is the result is considered highly statistically significant, and you would reject the null hypothesis at almost any conventional significant threshold. Example, right, these are the, because we have taken data at the 95%, right, because by default it is 95%, so alpha is 0.05. So our p-value, it is less than 0.05. So we can say that, right, finally we had framed this stretch p Mann-Whitney degree of freedom, sorry, data frame, this is, and finally we can say when the p-value is less than, this would print this statement, otherwise this would the print this statement. And once we have run this, and finally in our case the p value is small, so we reject the null hypothesis and conclude that distribution of the private owned mines output is significantly different from government owned mines output. But now we come to the another condition. Another condition is which one is lesser as compared to, I mean, out of these, okay, fine. In this statement, we can say in both these output, there is the distribution is differ, right? It's not same. So what we have to do, stats P equal to, this one is the mann-whitney data frame, mine and output alternative we have taken less, right? So there is the print, this one is the function is, we have to run this, and after that p value it is less than 0.05, then we can say the p value is small. So we reject the null hypothesis and conclude that government mines output is lesser than private owned mine output. But alternate hypothesis is the p value is large, so we fail to reject null hypothesis, and I mean this would be print and conclude that no significant difference in distribution of government owned and private owned mines. So ultimately we have to run, and finally you can see these are the values, and this value it is. So p value is small, so we reject the null hypothesis and conclude the government mines output is lesser than private owned mine output. Right. So finally, this one is the, we can say, right. And after that, we will move ahead when there is the greater. So stats, here is mann-whitney test. And again, now alternative, we had used greater. And here is when the p value is less than, it would print this output. The p value is small, so we reject the null hypothesis and conclude that government mines output is larger than private owned mine output. And otherwise, the p value is larger, so we fail to reject the null hypothesis and conclude that private mines output is larger than the government owned mine output, because we are using this thing, right? So ultimately this is our, this is the output. So I hope this video would be helpful to you, how we are going to conduct on the independent data, two different sample sites from two different population, how we can run mann-whitney U test. So I hope this video would be helpful to you. So stay tuned, keep watching.